So Caitlin Tucker is an organic consultant with the Rodale Institute. Caitlin joined the Rodale Institute consulting team in January of 2022 and is excited to support farmers across the greater New York transition to organic production. She received her BS in plant sciences from the University of Missouri. She is currently pursuing a master's degree in entomology with a focus on integrated pest management from the University of Kentucky. And prior to joining the Rodale Institute, Caitlin worked for the Cornell Vegetable Program for several years, where she served vegetable producers across Western New York through education, research, and production assistance. Thank you, Caitlin, for being here today.
Hi, everyone. Good morning. I'm really just a certified bug nerd, like vegetable nerd. That's like all you need to know about my credentials. Really excited you all are here today. Really excited for those of you that are joining us online. There's the camera. This is my first trip to Massachusetts. This is also my first NOFA summer conference. So it's been a wonderful trip for me overall. And yeah, I am based out of Buffalo, New York. I work for Rodale Institute for their organic consulting department. I'll talk a little bit more about that in the next slide. But we are going to nerd out about natural enemies, AKA insect allies in our gardens, on our farms, so that we can help them do their job of managing pests in the agro ecosystems that we're working in. Okay, so usually when I tell people that I work for Rodale Institute and I'm based out of Buffalo, New York, they're like, oh, I didn't know Rodale was in New York. Do you all have a farm there? No, they have me. I am a singular individual working as a consultant, as Rosemary said, to help farmers across New York transition to organic production. Our mothership, Rodale Institute, is very much still located in Kutztown, Pennsylvania. And for those of you that aren't familiar with our organization, we've been around for 75 years as of this October. And we are a nonprofit that's dedicated to agricultural research and education, specifically organic agriculture research and education. And we exist to help consumers and farmers alike really see this important connection between healthy soils, healthy food, and healthy people. Back in 2019 is when the consulting department was launched. We recognized that there was a need to actually have people on the ground helping farmers to understand what it means to grow food, to raise animals organically. And so with funding from the state of Pennsylvania through their state farm bill, the consulting department was launched and existed primarily to serve just growers in PA. It didn't take long to get calls from farmers outside of PA. They were like, hey, can you help us too? So we're 3 years young, and in that time, by the end of this month, we will have 13 to 14 consultants across the US in various places, providing technical assistance to growers. Like I said, sometimes that means helping them to achieve organic certification, but we realize certification is not the end goal for every grower for any number of reasons. We're also there to just help them improve their practices in general. So if you have more questions about what we do as organic consultants, please feel free to find me at the end of the presentation. My contact information will also be up on the slides. But we're here to talk about bugs. And before I jump in, are there any other entomologists in the room? You have to tell me. You are, awesome. Anyone else?
How often do you get yes to that question?
Not very, but it's not, I didn't realize you were also an entomologist. That's amazing. So then I can't say whatever I want to say about bugs. No, I'm just joking. But for this presentation, we're not going to get too caught up in taxonomy and classification of insects. I'm probably going to refer to all of these creatures as bugs, even if they're not true bugs. Also going to lump spiders and mites into this conversation. So let's not worry about taxonomy right now. But I do want to define a few things moving forward so that we're all kind of operating with the same language. I realize some of these terms might be familiar or not familiar to some of you. The first thing, well, you're probably all familiar with what a pest is, but I do want to talk about this because it's very subjective and it's very much driven by us, right? Like we are assigning good bug, bad bug categories to insects from our perspective on how they might interfere with crops that we are growing for food, with other plants that we may not be growing for food, but flowers, other ornamentals, trees. In general, there are organisms that cause harm to those things, animals as well, or people. But reality check, insects, good or bad, friend or foe, are a natural part of our agro ecosystems. And even more importantly, less than 1% of all insects out there are actually, what we define as pests. So there are a lot of good ones out there. And at the end of the day, when we are
I'm laughing at your answer.
Yeah. At the end of the day, our goal for pest management is not to eliminate every pest out there. That is not feasible. It's not attainable. We don't want that. If I stepped onto your farm and I didn't see a single pest, I would actually be concerned about how you are getting rid of those creatures on the farm. No, our goal for pests is to rather keep their populations below a damaging level. And I'll talk a little bit more about thresholds later on in this presentation. Some other terms that kind of float around in this space related to integrated pest management. There are a lot of them. Let's walk through how they are related. Integrated pest management, or IPM, is a sustainable approach to managing pests that combines all of the tools in our toolbox. These are cultural tools, like sanitation, planting resistant varieties. It could be crop rotation, managing weeds. We've got mechanical methods, getting out there and hand removing insects off of your plants, using traps, using barriers, using insect exclusion netting. Chemical tools, insecticides, miticides, they are still a tool in our toolbox. There is a time where it might make sense to use them and use them responsibly. And then there are biological controls. So biological control specifically refers to the management, the suppression of a pest using other living organisms. This is often shortened to biocontrol, one and the same. And the creatures that do that management, we often call them natural enemies. You could also call them beneficial insects. Beneficial insects, in my mind, is a more umbrella term for any insect that provides an important ecosystem service. But natural enemies specifically is referring to those that do pest control. For pest management, natural enemies look like pathogens. We are not talking about pathogens today, but that would be any beneficial bacteria, fungi, virus. The ones that we are talking about today are predators and parasitoids. You could also call them parasites. So predators are insects that attack, hunt, and consume their prey. They are what we call generalist feeders, meaning they eat a wide variety of pests in the environment. And as an example, lady beetles will eat aphids, they'll eat thrips, they'll eat mites. They're not too picky. They vary a lot in size. So we have something, they vary in size from minute, right? We have this minute pirate bug that's just very teeny tiny. You would not notice it unless you were like, your face was like in your vegetable crops, like looking intensely at a leaf. We have larger predators like praying mantises, and then we have everything in between, like lady beetles, predatory wasps. We've got yellow garden spiders, other spiders, really any type of spider is going to be a predatory ally in our gardens. We've got predatory thrips, assassin bugs. So a lot of different types of predatory allies. Parasitoids, on the other hand, are those insects that require a living host to complete their life cycle. So they will typically lay their egg inside another egg, possibly, or the larval form of an insect, maybe the adult form of an insect. And that egg develops within inside the host, and it feeds on the host from within inside it. Most are quite small. We have a number of parasitic wasps out there, many parasitic flies, but we can also have larger parasitic insects like wasps that fall in the Ichneumonidae family. They're typically larger. They can be identified by their ovipositor, which is how they lay their eggs. It's typically long. In fact, there are others where it's even more elongate than this. And some key things about parasitoids are that they are the opposite of generalists. They are specialists. They require a specific host to complete their life cycle. If that host is not in the environment, you're probably not going to see much of that particular parasitic insect. And then even more important to consider is that control is not immediate. It's not like a praying mantis is out there, attacking a cucumber beetle, and like once it's munching on it, that beetle's done. It's gone. Whereas with a parasitoid, when it lays its eggs inside of a host, that host is going to keep living for some time, sustaining those larvae as they mature inside of it. In fact, some parasitism causes hosts, pests, to be more voracious feeders in order to continue to support those developing larvae. Very cool stuff. This feather-legged fly I actually just found yesterday around campus. Tachinid flies are a big group of parasitoids. Flies in general are hard to ID, but tachinid flies, one of their most characteristic traits is these bristles, like projecting off of their bodies. So if you see a fly with those bristles, chances are it's probably a tachinid fly. And then up here, we have Aphidius colmani. This is a parasitic wasp. Teeny tiny. Like I don't have any scale indicators on any of these photos. I apologize, but these are very small. All right. If there's one message that I drive home today, it's the importance of properly identifying natural enemies and pests, but that's a different, presentation. And the biggest reason you need to know how to identify natural enemies is that if you are confusing them for a pest, you might risk harming them, spraying an insecticide, killing them, however you go about it. We don't want that, right? On the flip side, you might risk letting a pest population go unchecked if not properly ID'd. And many natural enemies out there have a number of lookalikes. And so I want to walk you through some examples, and I am going to ask for some audience participation. I'll try to keep an eye on the chat box as well for this. So we have a number of beetles up here, all in the Chrysomelidae family. They are not all friends. And I'm curious to know if you know which one of these or multiple are not friends. So raise of hands for A, if we think it's a beneficial. Okay. B, we got one. C, beneficial. One, okay. D. All right, seems like most people recognize D. What about E? This looks a little different, right? Than a lady beetle. No hands up for E. And then F, I don't know if you can see it, that's a black and white beetle. Any hands for E or for F? No. Okay, you seem really excited to find out the answer. This is fun. There's only one bad leaf beetle on this image or on this slide here, and that's the Mexican bean beetle in the top left. It looks very similar to a lady beetle, right? It's just orange, like a bit orangier, and there are lady beetles that have orange coloration, so it's often confused for a beneficial. Let's, this middle one, the twice stabbed lady beetle. I don't know who names these things, but you can tell it's the twice stabbed lady beetle. Well, maybe not, but it's got two little red dots on its back here, hence twice stabbed. This is a beautiful eye-spotted lady beetle. I found this in my yard and it's like, oh, this is amazing. Is this a lady beetle? It is. This is pretty readily identified as a lady beetle. This is the multicolored Asian beetle, a non-native lady beetle species, but still providing important pest control. This one is often not thought to be a beneficial lady beetle because it's more elongate, right? And it's pink, but still beneficial. And there are a number of species out there that have black and white coloration, this one being the checker spot lady beetle. All of these, excluding the Mexican bean beetle, are beneficials. They all eat aphids, they all eat thrips, they all eat mites for the most part. All good to have in the yard.
Question.
Yes.
What does the Mexican bean beetle molest?
Legumes, beans. It's a pretty big pest of soybean in particular, but it will go after any type of legume crop.
Another question, this doesn't make it
Yeah.
not beneficial, but does the multicolored Asian lady beetle eat other native lady beetles? as far as you know?
That's a good question. And I don't think so because it's, I don't know that any lady beetles, we have another entomologist in the room. I don't think lady beetles eat other lady beetles.
Like
They eat
the
smaller,
larva
yeah.
or something?
Yeah, they're all going to eat the aphids, the thrips, mites, that all of the lady beetles typically go after the same food sources.
Do they go after aphids in their beetle stage or is that more in the larvae stage?
The larval stage of lady beetles they're the voracious eaters of pests, but adult lady beetles will also eat aphids, just not at as high of a rate. Yeah.
Do birds eat all of these?
Do birds eat all of them? I'm sure they do. Like birds don't know which one's a good bug and a bad bug, right? Yeah.
That Mexican bean beetle, are those the ones that have been in the windows?
No, that is actually probably going to be your multicolored Asian lady beetle that comes in and overwinters
They look
inside.
very much alike, yeah.
They do, yeah.
The color is only slightly different.
Mm-hmm. Yeah, there's so much variation just with lady beetles alone, and that's why I have some handouts here that I'll give you that go into all of the different lady beetle, well, not all of them, but some of the different lady beetle species out there. Okay. Now we have 4 stink bugs in the Pentatomidae family. They are not all enemies. So again, we're going to do raise of hands. Raise of hands if you think A is a bad bug. No hands. I don't know if anyone's saying anything in the chat. B. Got a few people that think yes, B is bad. C. Some hands. D. Couple, like, why not? We're gonna find out anyway. Just tell us, Caitlin. So the 2 on the top are actually bad bugs. Up here again, twice stabbed stink bug. I I don't know. It's just like if it has 2 red dots on its back, we're gonna say it's been stabbed twice and call it a twice stabbed stink bug. I think it's also, its other name is like the wee harlequin bug. This is a feeder of plants, as is the brown marmorated stink bug, which is an invasive stink bug species. This one also comes into your homes in the cooler winter months. The bottom 2 are actually beneficial though. This is the spined soldier bug and the 2-spotted stink bug. The spined soldier bug can be distinguished from the brown marmorated by focusing on its shoulders. Really think spined soldier has spined shoulders. So they have these little pointy projections on the shoulders there, whereas the brown marmorated, its shoulders are rounded. And then the 2-spotted stink bug, especially, is a really great predator of the Colorado potato beetle, both the adult beetle and the larvae as well. So definitely want to see these 2 in your yard on your farm. Okay, so along with just recognizing what our insect allies look like, I think it's important to understand their life cycles as well. Not every natural enemy looks the same throughout its entire life, right? At different stages, they look different. And when we start talking about creating beneficial habitat, it's also useful to know, when are they active? You may not see a lot of beetle predation in the day, and that's because beetles, spiders are primarily nocturnal. Where do they overwinter? How do they overwinter? Are they overwintering as eggs or as pupae or as adults? How long do they take to develop? How many generations per year? And an example I want to share with you on why it's so important to understand life cycles. I worked with a farmer a while back who was having a terrible infestation of cabbage aphid in their greenhouse. And they were like, I need to, I got to do something about this. I would love to try biocontrol. I'm like, well, okay, let's try a release of Aphidius colemanni, this parasitic wasp. And it was a over the phone consultation. So we didn't really get into very much of the detail about the biology of the insect. And I went out for a farm visit, and they said, Caitlin, I think that I'm getting some control. There seems to be less aphid population in my greenhouse, but what I'm also doing is I'm removing all of the leaves that are infested with aphids. I'm taking them out and I'm throwing them in the trash. Like, oh no. Okay, well, let's take a look at some of these leaves. So what happens with Aphidius colemanni, with many parasitic wasps, is when they parasitize an aphid, they lay their egg inside the aphid, right? That egg develops into a larval, and it eventually kills the host from within inside, leaving behind this little shell. I don't know if you can really make out the color, but it's like a tan shell of an aphid. That is a sign that biocontrol is happening. And if you're tossing all of those leaves out, you're also tossing out the next generation of your insect allies. So just one example of why it's important to know the life cycle. Here are some other photos, examples of how biocontrol is happening in your yard, on your farm, but it may not be recognizable because it's not in the stage that we typically recognize. This is a praying mantis, ootheca, an egg case, okay? We all know what praying mantis looks like for the most part, but maybe we don't recognize their eggs. Lacewings, beautiful little creatures, lay these teeny tiny little eggs on a fine, filamentous stalk off of vegetation. This is what they look like as adults. We've got lady beetle larvae, right? These look like miniature alligators. I often get questions about the pupa though. Like, what is this? Is that a Colorado potato beetle? It's like, No, it's, the lady beetle larvae progressing into its next developmental stage, and then it becomes a very recognizable lady beetle. Assuming it's not actually a Mexican bean beetle, right? No. We have a parasitized hornworm here. Has anyone seen these in their yards? Yes. Awesome. This is a good sign. Those are parasitic wasp babies that have been living off of that poor tomato hornworm that lives for, like I said, a period of time while it's being fed on internally. And this is the adult. It might not be the exact adult, but it's a teeny tiny parasitic wasp. This is one of my favorite predators. This is an aphid midge. What it does is it attacks aphids, it latches onto their legs and paralyzes them and then sucks out their insides. It's very cool. But could easily be overlooked if you're like not getting, your face right into your aphid infestation on whatever crop it happens to be. This is what it looks like as an adult. Again, not to scale, but a midge is a type of fly. Probably be very hard to recognize this in the environment. For insect identification, there are a number of resources out there. I'm a good old-fashioned field guides kind of gal, but there are limitations to field guides. They don't always have multiple pictures of each insect. And as we notice with lady beetles, there can be a ton of variation in color, in shape. And so it can be handy to like go online, do some like really good Googling, Bugwood, Bug Guide, insectidentification.org. These are all great sites. Can require some knowledge of insect classification in order to have like an efficient search. I find that if you just Google like the right terms, like fly, orange body with orange and black body, like sometimes you can bring up images and get where you need to go with identification. There are also apps. I've never used any of these apps personally. Seek by iNaturalist is a good one. I believe it's free. This was used for a pest presentation, but if you searched for spotted cucumber beetle, you're going to get hundreds of images that everyone has uploaded. And so you can really readily see all of that variation that exists. Bug identifier, picture insect, bugs detect. Some of these do require a subscription. Has anyone used one of these apps? Yes. Which ones?
iNaturalist.
Good?
Yeah, pretty good.
Other folks have used iNaturalist?
It's great.
It's like a social, well, not social, but like other people could also like, basically comment on it.
They help to identify
Yeah.
things?
Yeah.
Awesome. Okay. All right, we've got thumbs up for Seek by iNaturalist. Two other resources I have. I have a natural enemy field guide for you all. This is a nice one-sheeter with some of the most common natural enemies that you would find. This came out of the Great Lakes Urban Agriculture Working Group. For folks online, you can access a downloadable version of this with this QR code here. This resource came out really recently from Cornell Cooperative Extension and New York State IPM. It does say beneficial insects on New York City farms. All of the insects in here can be found on rural farms, in gardens as well. But it's in a nice like pocketbook format. So really easy to have while you're running out to the garden. And that QR code will take you there. How am I doing on time? Okay. Okay, so let's talk about conserving natural enemies. This approach is called conservation biocontrol. And the whole purpose of conservation biocontrol is to support natural enemies through habitat modification. Through that habitat modification, we are providing sources of food, we are providing shelter, overwintering habitat, reproduction sites, and so on. And this does take time, labor, and intention to implement if you don't already have beneficial habitat. And you'll see what I mean by intention over the next few slides. Here are some examples of some beneficial habitat from urban farms that I've worked with in Buffalo, New York. Lots of beautiful sources of food, shelter, habitat, or overwintering habitat, all of those things that they need. Food specifically is something that we want to pay attention to. Just as we have different nutritional needs throughout different stages of our lives, so do insects. So food needs are going to vary from species to species, but also whether they are in the larval form or in the adult form. Pollen and nectar are important requirements for a lot of adult forms of natural enemies. Pollen is a really great source of protein that's often required for egg laying, egg development. Nectar, a source of sugar, a source of energy is important, especially for those insects that fly and do a lot of foraging and hunting. But they'll also feed on other things like honeydew from aphids, yeast in the environment, and alternative prey. And what I mean by alternative prey it's not the same thing as alternative pests. Alternative pests do count, but sometimes you'll have a natural enemy that's feeding on a beneficial, like this ambush bug that's feeding on a bee. It happens, like, right? They don't know what's a good bug and a bad bug. But if you're supporting a diversity of insects in the environment, you're probably supporting a diversity of alternative prey for them as well. And really want to make sure that there's a continuous source of food. Early in the spring, during the growing season, later in the fall, as much as you can throughout the course of the growing season. And that would be through incorporating annuals and perennials. Cover cropping, if you're not cover cropping, I hope one of the first things you do when you get home is figure out how you can incorporate cover crops into your landscape. Cover crops are great. The vegetation alone as like a living mulch is beneficial for a lot of soil dwelling insects, beetles, spiders, and flowering species especially are great for, again, those sources of nectar and pollen. Has anyone planted buckwheat before? Yes, like how many insects does buckwheat attract? It's amazing. They love it. Other flowering species could be Lacey Phacelia, clover, vetch, a lot of different mustard, like brassicas. And of course, cover cropping is going to provide numerous other benefits besides pest control. That it would include improving soil health, fertility, tilth, supporting the soil dwelling micro and macro fauna, and so on. And I know cover cropping has historically been viewed as a practice that farmers implement, but you can cover crop in a home garden, even in raised beds. This was, I think it was sorghum Sudan that I had planted. Maybe I don't remember what it was, but you can cover crop in raised beds. So I encourage you to look into this practice. Other things that you can do in production areas, adding mulch. If you have walkways, mulch them, leaf litter, wood chip mulch, straw, again, supporting those soil dwelling insects. If you are familiar with our organization, you know we're really big on roller crimping, cover crop residue. That's going to provide beneficial habitat as well. Permanent raised bed systems are great because you're reducing the amount of soil disturbance. And in general, when we can minimize tillage, the frequency or the intensity, that's going to help support, again, those soil dwelling creatures. Beetle banks have been very popular in Europe and are starting to gain some traction here in the US. These are, as the name implies, a habitat that supports beetle species. They are raised elongated berms, or it could be like mounds in a home garden that are planted with native bunch grasses. And you could also incorporate some native wildflower species in here as well. General recommendation, for every 50 acres, you have one beetle bank. This is an example from the Hudson Valley Farm Hub. This is their nice aerial view of their beetle bank in the field. They have been doing a lot of work around beetle banks that you can read more about going to this QR code here. Other things you can do, practice polyculture. Having a diverse cropping system in general is great for pest management, for supporting insect allies. And that looks like intercropping. It looks like companion planting. It looks like including insectary strips into the landscape. Again, incorporate perennials so that you have food sources, overwintering habitat, reproduction habitat throughout the year. And please do wait to deal with perennial cleanup until spring, like as late as possible, because as you can see here, there are creatures that require those perennial plantings, that woody, shrubby vegetation for reproduction. This was, I don't even know what plant this is, but this was at Rodale Institute back in May, and it is just covered in praying mantis egg cases. And had this been cleaned up in the fall, then maybe these wouldn't be here. Yes.
If you find that a place where you have to remove it, can you remove that case, put it in somewhere else, and it'll
Yeah.
still produce?
Yeah, I think so. Yeah. And that's, I'm glad you brought that up, because sometimes it's not feasible to leave vegetation where it is, but you can certainly relocate it. Other questions? Companion planting. I know folks love companion planting. I do too. There is a newish book that's come out that actually digs into science-based companion planting. Not that we need research to necessarily validate some of these practices, but it is always nice to see that, okay, yes, it does work. I'll share that at the end. But when we are looking for companion plants, you can't go wrong with plants that fall in the mint, carrot, aster, brassica families. A lot of these flowers have, plants have flowers that are short and shallow, which makes them much more accessible to teeny tiny parasitic insects that need that pollen and nectar. If you do want to plant an insectary strip, this is really just a strip of plants that supports insect growth and development. There's a resource that Rodale has put out, inviting insect allies to your farm using insectary strips. There is a focus specifically on cucumber beetles, but Gladys did a really great job of walking through all of the considerations that need to go into the planning process. Things like, what pests are you targeting? If you know what pest you're trying to target, then you know what beneficial insects you need to invite. If you know what beneficial insects you need to invite, then that will inform what plants you need to grow to invite those beneficials. But you also want to think about things like soil requirements, light requirements. Do you need to be planting drought tolerant species, moist tolerant species, shade tolerant species, and so on. And plant and flower structure is something to consider as well. So plants like dill that have upright, stalky structures are great to include into the landscape because you could have, it doesn't get crowded on here, right? Like there are tons of sources of nectar and pollen readily available. You could have 20 different insects visiting this plant at once. In non-production areas, because I do recognize that not everyone's going to be able to do some of this stuff, like where they're growing, where they're farming. You could have hedgerows. This is a hedgerow on the side of our garden. It's a non-native species, but it is providing an important service and we're keeping it in check. Other things like contour buffer strips, windbreaks, wood brush piles, stone piles, all provide habitat for different species of natural enemies. Did anyone participate in No Mow May? Yeah, got some, awesome. We went as long as we could into the month of May. It got a little out of hand by that last week. But if you can reduce mowing frequency, like having flowering plants that early in the spring is incredibly important because there's not a lot flowering. And so you're providing very early season nectar, pollen sources. You're providing the vegetation again is beneficial. If you do have to mow, consider mowing, like doing some alternating type of mowing. Our neighbors, I'm sure, like look out their window and wonder what we're doing when we only mow like weird paths across our yard. But as the longer you can keep that habitat available, the better it's going to be for pest control. And strongly encourage you to consider planting native plants to support native natural enemies. Why? Because our natural enemies that are native here have co-evolved for thousands of years with native plants. And not to mention you have the added benefit that they are adapted to your region. They are resilient. And especially in climate now, in the middle of this drought, when I looked around this campus, what did I still see flowering? Our native species, the goldenrod, the coneflower, the aster. So do prioritize those. I'm not a native plant expert, but I do know that there are concerns around nativars, and I want to bring it up so that you exercise some caution when you are searching for native plant species. Nativars are just cultivated varieties of native plants that have been bred largely for things that we want as people. We want different bloom sizes, different bloom shapes, different bloom color. Maybe we want variegation. Maybe we just like the general aesthetics. The issue in breeding plants, specifically native plants, for things that we love and enjoy, means that they might not be suitable for natural enemies. And so you have, beautiful echinacea here that this is what I recognize as a native ecotype. But you go into any catalog and now you have dark pinks, light pinks, variegation, orange, different bloom shapes. And all of this makes me wonder how this is impacting our native natural enemies or just beneficial insects in general, pollinators especially. Concerns here is that they might not be as attractive to pollinators. They may not provide similar nutrition. They might not produce seeds, which is an issue if we are looking for those native plant species to propagate and have some longevity in the environment. Really important is that they may not facilitate pollination. If we are inbreeding for one trait, we might be affecting the actual structure of the flowers, which directly impacts whether natural enemies can access that pollen and nectar. So exercise caution there. I do see too often native plants sold in the greenhouse, in the nursery, when in actuality they are nativars. So banker plants are another way you can provide beneficial habitat in a food source, a continuous food source for natural enemies. When natural enemies eat all of their prey, their population crashes. We do not want that. We want a continuous supply of natural enemies, which means we kind of need a continuous source of pests, but we don't want a continuous source of pests. So how do we deal with this? This is where a banker plant system comes into play, where you are providing an alternative prey to a natural enemy. It can be used in the field and indoors. I see it mostly used in enclosed environments like high tunnels, greenhouses. And the system I want to share with you as an example is with hanging baskets of barley, wheat, and oats. So these grassy species get attacked by the bird cherry oat aphid, which is only a pest of those grassy species, not a pest of eggplant, not a pest of tomato, not a pest of lettuce. And if you were to plant, hanging baskets of these crops and inoculate them with the aphids, they're only going to feed on those grassy species. But if you have Aphidius colemanni or another parasitic wasp in the environment that's fed on all of your cabbage aphid, now it has the bird cherry oat aphid to feast upon when the cabbage aphid runs out. Some tips for implementing a banker plant system: you really need to make sure that the alternative pest is not a pest of the crop that you are wanting to grow. You also need to add fresh plants on a regular basis. Those aphids will eventually overtake the wheat in those hanging baskets, so you do need to replenish those. And we also need to replenish them because hyperparasites can build up. So yes, our parasitoids also have parasitoids that attack them. Yes.
So if you have a landscape with a lot of diverse native wild plants all around and close to where you're cultivating fields, or even close to a hoop house where that is a little more protected growing environment, do you really need to do this?
No, not necessarily. In an enclosed system, it can be especially useful because even though high tunnels and caterpillar tunnels do allow for some, movement, there's not a lot. They pretty much serve as a barrier for insects moving in and out of the high tunnel or a greenhouse. So that's why they're especially beneficial indoors. I would say outside in the field, you probably don't need to implement a banker plant system, but it is an option if there's something specific you're trying to tackle.
Just seems like a lot of work.
Oh, it is. Don't get me wrong. Yeah, it is a lot of work, but it's a very cool system. If you want to read up more about this, the University of Vermont has done some excellent research. This QR code will take you to that. All right. Okay, the second approach I want to talk about for pest control is introducing natural enemies. This is augmentative biocontrol. This is different from conserving a naturally existing population. We are bringing insects in to do one of two things. One, we need to quickly knock down a pest population because it's getting out of hand, or two, we're just trying to supplement the native beneficial insect populations. This is not intended to be a permanent solution. This is a lot of work. This is a lot of money to do this. But there are certain environments where it makes sense. Those environments, again, are indoor growing environments, greenhouses, high tunnels, caterpillar tunnels. If you do go this route, when you purchase mass-reared insects, release them immediately. These are living creatures. They cannot survive in a shaker bottle for an extended period of time. They aren't often they're sometimes shipped with a source of food depending on the stage of insect that is being shipped, but release them immediately. Also check for issues when they arrive. Things like temperature extremes in shipping, shipping delays, condensation from ice packs, if they're included, can all hurt those natural enemies, and you want to know immediately if they're alive or not, so you can contact the company and ask for a new shipment. And strongly advise you to purchase from reputable businesses. I see natural enemies being offered for sale on Amazon and eBay and Etsy. I think I've even seen natural enemies. Yeah, like there's a lot of stuff out there on Etsy. I love Etsy, but do purchase from reputable businesses. These are companies that are doing quality checks on their populations. Some, this is not extensive, but some that are pretty popular with growers I work with are Arbico Organics, IPM Labs, Copper, BioBest. Lost Ladybug Rescue, I mentioned specifically for New York residents. Is anyone? Awesome. This is a really cool project that's being spearheaded by some researchers at Cornell. They are trying to revive the native 9-spotted lady beetle in New York. And there's some citizen science going on as well, where they're asking people to like send in photos if they find one of these beetles in their yards or wherever. And they do offer shipments of the 9-spotted lady beetle for growers to release. So when you are choosing a natural enemy, there are a few things you need to consider. One, what pests are you trying to control? Not every natural enemy eats every pest in the environment. How quickly do you need pest control? Some adults, like green lacewing, actually feed primarily on pollen and nectar. So if you're releasing adult lacewings into your greenhouse, just know that you're not going to get immediate thrips management from them. You should be releasing the juvenile stage. And these, again, they're living creatures. They are susceptible to temperature extremes, they have preferences for relative humidity. So typically when you order one of these, they'll give you a profile on, Cucurumus really likes temperatures between 75 and 90 and a relative humidity of 60%. In fact, if the temperature isn't ideal, they may stop feeding entirely. Some predatory mites will actually stop feeding, go down to the bottom of the vegetation to seek shelter. And you don't want that. You want pest control. And you also want to consider compatibility with other natural enemies. This goes back to, if you're releasing a lady beetle and a predatory mite into your high tunnel, that lady beetle might eat your predatory mite as well, in addition to the pest mite. Compatibility with crops. Tomatoes, especially, that have really resinous trichomes, these hairs, can actually trap natural enemies. There's been some research done specifically on Amblysia swerskii, which is a predatory mite. And you want to consider compatibility with pesticides if you're also using those. So a number of companies have like cool little, it's not a calculator, I'm blanking on the word, cool little feature where you can select the natural enemy in question and the pesticide that you're wanting to apply, and it will tell you how toxic that pesticide might be to your natural enemy. So BioBest has one, BioWorks has one. This one is out of Coppert, and it goes one step further in giving you information on, like, if you are applying an insecticide that's in a dust formulation versus a drench, it's going to impact that native or that natural enemy differently. Okay, when you are releasing natural enemies, do so at the first sign of the pest. Biocontrol works best as sort of a preventative measure. If your brassicas look like this and are covered in aphids, releasing a predatory lady beetle is, it's an uphill battle. Like, let's just say that. And even then, they're probably not going to keep, predate on all of those aphids. That just doesn't really happen in the environment. You want to release at the appropriate rate, and that depends on the size of the area you're trying to manage, the severity of the pest. and strongly encourage you to stagger releases so that you have a continuous supply of that natural enemy at various developmental stages. There are issues, though, with mass-reared insects. Another one, a cautionary statement. A lot of the natural enemies available for purchase may not be native to your region. Case in point, the Chinese mantid is often sold by IPM companies not native to Turtle Island, but it is out there. It's pretty well established. And one way, just as a fun fact, to distinguish between the Chinese mantid and the native Carolina mantid is that their egg sacs are actually like shorter and more round. So if you see this in the environment, it's the Chinese mantid species. Other issues, field collected wild populations. This often happens with lady beetles. They may not be adapted to your particular climate, the temperature, and then that means they may not thrive. And then you also risk transferring parasites, pathogens to native natural enemies in your area. The last thing I want to talk about is insecticides, and I don't love talking about insecticides, but let's be real here. People use insecticides in their gardens and on their farms, and there are best practices to follow here as well. If you are an organic farmer, certified organic farmer, especially, this is important to know. I hope you know it already, but you are required to use preventative pest practices first and foremost. Crop rotation, resistant varieties, trap cropping, developing beneficial habitat, augmentative pest control. Only when these practices are not sufficient in controlling a pest, only then are you allowed to come in with an approved biological or botanical insecticide. This is definitely a requirement for certified organic. I still think it's a best practice. Even if you're not going after certification, even if you're just a home gardener, insecticides should be a last resort. And one additional thing that should guide you on when an appropriate time to spray is a threshold. Now this is like, we're really getting into IPM here, so I won't be offended if like your eyes start to glaze over, and I'll try to make this easy to understand. Thresholds are guidelines for when you should spray for a pest, and it's dependent on the pest population. So cucumber beetle, spotted cucumber beetle, it will have, it'll be high and low population throughout the season, dependent on different factors: predation by insects, predation by birds, temperature, other weather conditions. But it exists. The average density of that population is defined by researchers. So this is average density you would expect in the environment. Maybe it's 3 cucumber beetles per plant. The economic threshold is the density of that population at which you need to take control. 90% of the time, we're talking about a spray, an insecticide spray, because that's really why economic thresholds were developed, to guide sprays. But this is when you need to take action, and you want to take action at this point, which is, let's say it's 5 beetles per cucumber plant, so that you don't reach the economic injury level, which is the population at which you are now starting to see damage that is impacting that crop economically. So to just kind of like work through this example, you have this pest population of cucumber beetle, and it's, it goes up and down, and we cross the economic threshold. At this point, this is when you spray, and only at that point. The population then crashes, rebounds a little bit, but it doesn't come back up above the threshold until here. This is when you spray, okay? that population goes down again, and later on in the season, for whatever reason, the tractor broke, you had to go out of town, you missed a week in scouting your cucumber plants, that cucumber beetle population is now above the economic injury level. Maybe it's 10, 12 cucumber beetles per plant. You are now starting to see economic damage. So this is just something to further guide. If you do want to use insecticides, that, use them when the threshold dictates you should use them. This QR code will take you to thresholds for a number of vegetable pests. This was out of the University of Maryland. There are limitations here for thresholds. Biggest limitation is they're not available for every pest, crop, combination. They're certainly not available if you have multiple pests on a particular crop. Like, let's say you have aphids and mites. You don't know what that combined threshold is. And it really doesn't apply for ornamental crops where we really value the aesthetics. One mite might be the threshold for certain flowers. One Japanese beetle, right, might be the threshold. And you do have to do regular scouting in order to guide your decision-making here. A different approach to thresholds that I just want to introduce, because it's a newer concept and there's not a lot out here, is shifting the focus from how many pests in the environment mean I need to spray to how many natural enemies in the environment mean I'm okay and I don't need to spray. This is called a biological control threshold. And so what that would look like is how many lady beetle larvae per plant are enough to control aphids. I don't know. How many parasitized aphids on my tomato mean that I don't need to spray? I don't know. It's a newer approach to IPM. So there are very few published thresholds here, and predator prey relationships can be very complex, which I think is hindering, progress in this area, but it is just something I want you to think about when you go out. To find pesticides approved for organic production, one way to do that is to go to OMRI, that's the Organic Materials Review Institute. You can search for a particular product or a particular active ingredient online. So I've brought up Pyganic here. You want to pay attention to two things. The status, whether it's allowed with restrictions, or prohibited. Typically with insecticides, if it says allowed with restrictions, that restriction is almost always that you have to be doing preventative pest practices before you can use this. So you can also check to see if a product has that OMRI sticker on it. This isn't always the case because you have to pay to get that sticker on your product, and some companies, for whatever reason, don't want to go that route. For gardeners, another thing you can look for is this little label here that's like 3 little leaves. It says for organic gardening, and it is for use in home gardens. If we have farmers out here, this label does not permit you to use it in farm production. Some common organic insecticides available. We've got neem oil, azadirachtin, which is a derivative of neem. Bacillus thuringiensis, or BT, is a common one. Diatomaceous earth, insecticidal soaps, kaolin clay, pyrethrin, spinosad. All organic, all approved for organic production. Doesn't mean that they're not going to harm natural enemies as well. Spinosad and pyrethrin especially are still broad spectrum insecticides, so do be cautious when you are using them. I have some best practices in the next slide. If you really want to get into organic pesticides and risks to pollinators, this is an awesome resource from the Xerces Society that, again, QR code will take you there. Oh. There we go. So if you do decide to spray an insecticide, minimize those broad spectrums as much as possible. They they're going to hurt a wide variety of pests and natural enemies. Really do follow label instructions. I can't emphasize this enough. I do meet people who don't understand that the label is the law. This is how you're supposed to apply the product. This is the rate you are supposed to apply the product. These are the crops you are supposed to apply the product to. And if it's not on there, you're not supposed to do it. Apply pesticides in appropriate weather conditions. Here we're trying to minimize drift, of course. A really good practice to minimize exposure to natural enemies is to apply very early in the day or later in the evening. Most insects are very active during the middle of the day, and so you want to apply them at times of the day when they are less active. Avoid applying directly to flowering plants. Spot treat where possible. Sometimes you don't need to spray, your whole potato planting. It might just be 1 or 2 plants, especially if you catch the problem early enough in the season. And apply to the appropriate part of the plant to increase efficacy. Yes, go ahead.
I just wanted to ask what you define as early and late.
That's a good question. So I don't think that I've ever defined it. So you're putting me on the spot here. I would say before 10 a.m. in the morning. And in fact, that's why I wanted this talk to be at 10 a.m. in case we do get to go outside and look for insects, because they're going to be active around this time. So before 10 a.m. in the evening, I would say probably after 5:36. I mean, I'm sort of making this up here. Rosemary, do you have any thoughts on that?
Early and late.
Yeah, early and late. Yes, you have something to add?
I don't know if we need to define that by time. I define it by dew. So in other words.
Oh, great.
Is it dew, is it good to spray before or after the dew leaves in the morning? Is
Yeah.
it good to spray before or after the dew comes back in the evening?
That is a really great suggestion. I
No,
would
don't know
follow.
the answer to
No,
that.
I would follow that. I would follow that because that dew is also going to impact how how much that particular pesticide is going to stick to the plant. So I don't know, I kind of like that, applying before the dew leaves the plants and before it shows up in the evening. Any other thoughts on that? Do you have something?
I was just gonna say that early and late, it definitely helps to minimize risk, but there are, insects they hang out on the
Thank you.
plants.
That's a good point. Yeah, there's still going to be beneficials out there. It's just you're minimizing exposure. And the apply to appropriate part of the plant, I want to stress, and I don't have the photo here, but a lot of pests hang out on the underside of the leaves. So if you're just spraying a pesticide over the top, you're not getting that product where it needs to be to provide control. Okay, some conclusions here. Oh yeah, go ahead.
How do you get it on the bottom of the leaf you're at and for the tail?
Backpack sprayers could be used, where you could take the nozzle and spray it underneath the leaves. Yeah, that's my go-to. Has anyone else used something else? If
It's an
it,
electrostatic sprayer.
yeah, okay, so we've got a farmer here.
It's the best.
Yeah.
Best you can do.
Yeah,
Charges the particles, hits the underside and the overside. They're expensive though.
yeah. And especially when we start to talk about pesticides, there's so much more we could cover here. I'm not going to get into it, but there's also opportunity to talk about adjuvants here that will ensure increase efficacy of a product or how much it will stick to the plant. We can talk about systemic, formulations of pesticides, systemic or non-systemic, but yes.
I think a good strategy is to integrate trap crops with
Yes,
habitat for the beneficial.
yes,
For example, hairy vetch is a trap crop for aphids, in my observation. So if the aphids are congregating on the hairy vetch, they're not on your vegetables.
mhm,
If you have your hairy vetch growing among your vegetables, let's say, and then your beneficials can find them there.
Yep, I'm so glad you brought that up, and I wish we had more time because trap cropping is something I haven't mentioned, a really great practice. In this approach, you are planting a specific crop that is a trap. It's most often used as a sacrificial crop that is highly attractive to a particular pest. And so that pest migrates away from the crop you're trying to manage or to save, to grow, to sell, to that trap crop. And once it's on that trap crop, you can either just spray the trap crop, so you don't actually have to spray your cash crop, or that trap crop could also attract natural enemies as well. So you've got biocontrol happening in addition to, yes.
So an example in the, the winter squash category, I've noticed that cucumber beetles do not really care for the butter. No, my mind is blanking, but
The butternut?
The butternut, right? They much prefer maybe an heirloom, zucchini.
Mhm.
So if you have a few of those heirloom zucchinis, that's where they're gonna congregate, and you can take care of them, and meanwhile your butternut is pretty much okay, which is a better cash crop.
Yeah, blue Hubbard is also another common trap crop in that system. Yes.
So I'm trying to think of your example. I don't know that much about aphids, but I know, like, for instance, flea beetles are specific to certain families of crops.
Mm-hmm.
So in that particular case, if you've been hairy that's a legume. Are aphids specific to certain families of crops too, or are aphids general feeders that go on?
Different species of aphids feed on different species of crops. So there are cabbage aphids that feed primarily on different brassicas. There are some aphids that feed on the grassy species. So, and this is another reason why it's important that you know what pest you're trying to manage, whether you're doing anything we talked about today, or you want to do trap cropping specifically. Like in brassicas, I'm trying to recall, like really good trap crops are like mustard greens, for flea beetles specifically, mustard greens like pak choy, bok choy.
I think there's a daikon radishes, they're really good also.
Yeah, so, and there's, there's not as much research out there as I would love to see, because this is such a underutilized pest management practice. But there's enough out there that you could find different trap crops to plant for different systems. Yeah.
I was looking to hear about milky spore. It used to be okay organically, now it's not. Do you know why?
I do not. That's new to me. I'll have to look into that. Milky spore specifically for Japanese beetle management. Yeah, I wasn't aware that it wasn't improved anymore. I don't know. Have to ask.
We were told they're on the blueberry side.
Huh. Well, I'll have to look into that. Maybe did they say anything about it not being labeled for a blueberry?
No.
Okay. I don't know.
Are you aware of any research for woolly indulgent or control of woolly indulgent?
I am not. But, and that's a type of biocontrol we didn't talk about. So we talked about augmentative, conservation. The other biocontrol is classical biocontrol that's specifically for managing like invasive insect species by bringing in other non-native or native species to manage it. And so with woolly adelgid, I imagine if there's work being done, it's probably being done by the university, by state government, federal government, because usually those types of pests are handled like on like wide areas, like with spotted lanternfly, with spongy moth. Yes.
I know it was out of your purview, but another thing I find is extremely helpful in managing pests is inviting birds.
Yes.
Into your,
yeah.
Whatever kind of growing you're doing, hedgerows, birdhouses. There's a wonderful organization on the West Coast called the Wild Farm Alliance.
Yes.
They have a lot of information about how to invite birds, insect-eating birds into your garden.
Yeah. I'm so glad you mentioned that too. I thought about trying to include stuff like that. I'm like, okay, we're going to be here all day. Yes, there are more natural enemies out there beyond the arthropod insect natural enemies. Insectivorous birds, bats, different amphibians. So all of this habitat creation that we're talking about is also going to be beneficial for all of those other creatures as well. And actually, there was a study that came out recently, I think it came out of UMass, about insectivorous songbirds for pest control. So you might Google that. I don't recall the reference off the top of my head. I do want to quickly share some resources with you. These are a number of books that I have at home that I love and reference like on the daily. This Organic Gardener's Handbook and this Plant Partners can actually be found at the book vendor. Plant Partners is that science-based companion planting book that I was talking about. And I love this. Again, we don't always need science to like validate all of these practices that we've traditionally used in our landscapes, but it's nice to see that there is some validity, that research can validate it in some way. And let's see, this farming on native beneficial insects, great, a lot of different habitat recommendations. Two others, this is actually a downloadable version of this book if you don't want to buy it. I've pretty much deduced that they're almost identical. And these are other things that I saw at the vendor fair yesterday. Good bug, bad bug. We've got this pollinator garden deck went from, yes, farm up.
That's a plenty farm.
That's a plenty farm.
It's really fun.
Yeah, and geared towards pollinators, but a lot of the species included in the deck are going to be just beneficial to have in general. Some nice little simple, like short guides for insect identification. And I do have these handouts for folks. If you're interested, any other resources that folks want to share? Any other questions? I realize I haven't been.
I'm on the chat, don't worry.
Okay,
We don't have questions in the chat.
perfect. Yes.
I have a question. I have something eating my cabbage, right? And I think it's the cabbage one, right? Which has the two little dots on its wings.
Yes.
And I also read that they are distracted by dill and thyme, which indeed I have in the garden, and I use the butterflies on that plant, right? Now, does that mean that I don't have to worry about them anymore? Are they, and what is distracting about them? Are they going to lay their worms on the dill instead of on the cabbage?
Oh, we're getting like, I love this. So like something that's talked about in that Plant Partners book as well, but another approach to managing pests, having like companion plantings. Those companion plantings can put off volatile cues like scents, odors, that can make it difficult for pests to find that host crop. So they obscure it in a way. Maybe that's what's happening in this situation with the dill, and then it's putting off such a scent that it can't locate the host crop where it wants to lay its eggs. They can, companion plants also provide like visual obstruction as well. So that's why polyculture is great, because some insects, if they can't see it, if they can't find it through their olfactory system, they're going to move on. They're going to go try to find that host somewhere else. Yeah, we could get into like insect plant communication and volatile production like all day here. Yes.
I've been trying to formulate this question, so I'm going to ask for your forgiveness if I stumble.
That's all right.
But it's sort of related to the idea of like intercropping and polyculture. I'm wondering how you specifically or other folks at Rodale navigate like recommending plants well suited for companion planting and intercropping to farmers with lots of skepticism or high degrees of skepticism about like how to affect their yields. I'll share that like I'm coming from like a 30-acre diverse vegetable organic farm, and it's been hard. It's been difficult for me to kind of navigate those conversations with my coworkers and managers sometimes. So like, how do you inspire long-term buy-in or shifts in perspective?
That is a very good complex question. And I would say my approach is really farmer dependent. Like every relationship I have with a farmer is unique. And you do have to consider the goals for that farmer. Maybe pest management isn't the goal necessarily. Maybe it's weed management. But specifically with pest management, my approach would be to find a just one practice that they could implement. Like just start, if they don't want to complicate production itself, like find a way that you can incorporate habitat into the perimeter of the landscape. Or try insectary strips, try the beetle banks. Those are simple enough like habitats that I don't think that they would hinder like, crop production, especially if there's machinery involved too much. I'm not sure if I'm answering your question. Okay. Like, yes.
I just want to share something. So I let my cilantro self-seed in my hoop house. And when they go to flower, this year, when it was a sunny day, I literally see hundreds of parasitic wasps around a very small patch of the cilantro. And to me, that's something that's easy to let. To me, it wouldn't be a problem letting that grow in a field. And then you have your parasitic insects right there when you need them.
Yeah, I agree. And on a garden scale, I took this slide out because I don't know if we'd have time, but different natural enemies have different dispersion rates, meaning that like they travel varying distances. And so in like a small garden, you can have little islands, little pockets of beneficial habitat, like flowering cilantro, just a 4x8 raised bed of annual flowers. You don't have to transform the whole yard into beneficial habitat. On a larger scale, like a farm production scale, you do need more habitat. You want more interconnected habitat because those insects have to travel further to get to those sources of pollen or sources of nectar. Yes, go ahead.
I just have a quick question. Does the Rodale Institute do anything with nutritional pest management, as in like if you're using high amounts of nitrate, it calls out signals and blah, blah, blah.
Research wise, no, I don't believe anyone is doing any of that research. I do know that there's a lot of interest in optimizing plant health for pest and disease resistance. So there's no research going on. From a consulting standpoint, we are not going to recommend a specific product for optimizing plant health, but we could certainly have that conversation with the grower about like, is that where you're going? Like optimizing plant health for insect resistance?
Optimizing plant nutrition for.
Yes.
Yeah.
Okay. No research is happening in that field. I'll just put it that way. At Rodale. Yeah. Yes.
I still remember reading a long time ago the specific BTs for specific pests. And I think the most common one sold for gardeners and farmers is Kristaki, I think is the right. Is that good for most? Mainly I need it for cabbage worms and the potato beetle flower. Is that a general BT that would be good for a lot of different, or do I need a specific one for potato beetle?
I don't remember which one is most effective for potato beetle, but you are right in that there are different strains of BT that are more effective for different lepidopteran like pests. I don't recall like which one you need for potato beetle.
So the key word to your response was more effective. So I'm okay if it's not quite as effective as long as it's effective, but if it's zero effect, then that's what I'm more concerned about.
I just do not know off the top of my head. Rosemary, do you happen to know?
I don't know which one is post, but you should, whatever BT type it is, you should be able to.
I think specifically
Look it up.
for BTD or potato beetle.
Yeah.
For organic farmers are using Trident for a number of years.
What is the
Is that the
active
brand?
ingredient?
I think it's BT.
Okay,
It might be like a higher concentration. I actually just tried to look at the label. It's 14%, so it's pretty high, but
Yeah.
it was yeah, but so it's for strains SA10. I don't know. I know it's been off the market for many years. That's the thing about CPGs is it's developed consistently.
yes, yeah.
So quickly.
If, thank you for looking that up. I know we're like at time, but if you all are interested in seeing some biocontrol out here on the campus, I'm gonna head over. It's just like a couple minute walk over to this nice patch of milkweed. So if you're interested in joining me, just hang out unless there are any other questions.
So thank you, Caitlin,
Oh,
so much
yeah.
for your talk. Thank you.
Thank you for coming.